All right, let's talk about one of the most fundamental building blocks of pretty much any application, functions. But we're going to go way beyond the basics here. We're going to focus on how to write professional, super robust, and truly reusable function types in TypeScript.
So if you've ever found yourself just fighting with any types or, struggling to define a function that can handle different kinds of arguments, then you are in exactly the right place. Let's get into it.
Here's our game plan. We're going to start with the fundamentals, what a function's shape even is. Then we'll build on that to create some really flexible functions. From there, we'll tackle the more complex stuff and finish up with some best practices you can start using like today.
Okay, first up, the blueprints for your code. Just like any other value in TypeScript, functions have types, and there are really two main ways to describe them. So the most common way you'll see is the function type expression. And it looks almost exactly like an arrow function, which is super convenient. The syntax here, it's clearly telling TypeScript, hey, this is a function, it takes one string parameter called a, and it returns nothing, void. Now, one small but important detail, that parameter name, a in this case, is actually required.
But what if your function is also an object? I mean, this happens all the time in JavaScript, right? Think of a function that also has some properties attached to it, like a version number or something. For that, we need what's called a call signature. Notice the syntax is a little different here. It's part of an object type, and it uses a colon, not an arrow. This is how you describe something that is both callable and has properties.
So, here's the bottom line, the crucial difference. You use a function type expression for a plain old standalone function. But the moment you need to describe a function that also has properties, like say a description or some kind of metadata, you've got to reach for a call signature inside of an object type.
Okay, so now we know how to describe a function. Let's make them more powerful. This whole section is about going from rigid, single-purpose functions to ones that are super flexible and reusable, all thanks to a key feature called generics.
Let's look at a classic problem. You've got a function, it's supposed to get the first element of an array. Simple enough. But if you type the input array as any array, well, TypeScript has absolutely no idea what's inside. So what does it return? The dreaded any type. And this just completely defeats the purpose of using TypeScript in the first place because we lose all our type safety.
And here is the solution. Generics. It's magic. By adding this little type parameter, we create a link. We're basically telling TypeScript, hey, whatever type the elements in the input array are, that's the exact type this function's going to return. So if you pass in an array of strings, you get a string back. Pass in numbers, you get a number. Boom! Type safety is restored. But wait, what if your generic function needs to access a specific property, like .length? You can't just assume every possible type is going to have one. And this is where constraints come in. By adding extends length, number, we're making a promise to TypeScript. We're saying, don't worry, whatever type we pass into this function, I guarantee it will have a length property. And that makes our code safe.
Okay, this quote on the slide, this highlights a major gotcha with callbacks. When you're typing a callback for something like for each, you might be tempted to mark a parameter like index as optional. But don't do it. It can cause all sorts of problems. It tells TypeScript that the argument might be undefined, which leads to errors inside your callback, even if the function you're passing it to always provides it. The rule is simple. Only make a callback parameter optional if you actually plan on calling it without that argument.
All right, let's get into some of the more advanced patterns. In this section, we're going to tackle functions that can be called in multiple ways, and we'll see how to handle that notoriously tricky this keyword. Some functions can be called in totally different ways. The makeDate function is a perfect example. It can take a single timestamp, or it can take a month, a day, and a year. Function overloads let you define each of these valid ways to call the function, then you provide a single underlying implementation that's compatible with all of them and contains the actual logic.
But a little word of caution here. While overloads are really powerful, they can get complicated fast. The official guidance is pretty clear. If you can do the same thing with a simpler union type, you probably should. For instance, a function that gets the length of a string or an array is so much cleaner as len, x is string or any array than as two separate overloads. It's just easier to write and easier for TypeScript to figure out. So what about this? In some JavaScript patterns, especially with older callback-style APIs, the context of this is actually set by whatever is calling the function. TypeScript lets you handle this. You can declare the type of this as a special first parameter in your function. But be really careful here. This syntax only works with the function keyword. Arrow functions capture this from their surroundings, so they can't be used for this pattern at all.
Okay, to wrap things up, let's just go over a few key best practices. Think of these as rules of thumb that'll help you write cleaner, more maintainable function types.
When you're writing generic functions, try to follow these 3 rules. First, push type parameters down. This encourages TypeScript to infer the most specific type it can. Second, use fewer type parameters whenever possible. If a parameter doesn't connect 2 or more values in your function, it's probably just adding complexity for no reason. And finally, a good rule of thumb is that a type parameter should show up at least twice. That usually means it's doing its job of relating 2 things, like an input and an output, which is the whole point of using generics in the first place.
Finally, let's do a quickfire round on 3 other essential types. Void is for functions where you should just ignore the return value. Unknown is the type-safe version of any. It forces you to actually check its type before you can do anything with it. And never is for functions that truly, well, never return a value, like a function that always throws an error.
So, I'll leave you with this question. Your function types are more than just hints for the compiler. They're a form of documentation. They tell a story about what your code expects and what it produces. So, after this, take a look at your own code. Are your functions telling the right story? I really hope this helps you figure out how to do just that.